2.6, find rational zeros. The rational zero theorem, we are looking to find rational zeros. On previous sections, such as 2.5, they told us the numbers that we should be using in our synthetic division. Now it's going to be our job to have a polynomial and to come up with those factors and zeros ourselves. You can find these factors by what is called P over Q, P divided by Q. We have factors of the constant term divided by factors of the leading coefficient. Factors of the constant, a to the 0, and factors of the leading coefficient, a to the n. That is how we find the possible rational zeros. These are the possible ones. It doesn't mean that all of them will work. It doesn't mean that any of them will work. It just means that if they're going to work, these are the possible zeros. List the possible rational zeros of f using the rational zero theorem. That's going to be P divided by Q. So we're going to take factors of the constant. We have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4. Those are all factors that go into 12. Those are all numbers that are divisible by 12. Now, if you're going in order and using divisibility rules, when you see two factors that are right next to each other, that's how you know you're at the middle. So now 2 times 6 and 1 times 12. There's the factors of our constant divided by factors of the leading coefficient, which is 1. So all we have is plus or minus 1. So our possible rational zeros are 1 over 1, 2 over 1, 3 over 1, and so on. So plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, and plus or minus 12 over 1. Those are all the possibles that I would try with synthetic division. Example 2, find all the zeros. All right, so we're going to do P over Q, all the factors of 20, 1, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5. 4 times 5 is 20, so 2 times 10 and 1 times 20. And all of those are going to be over factors of the leading coefficient, plus or minus 1. So 1 over 1, 2 over 1, and so on. We have plus or minus 1, plus or minus 2 over 1, plus or minus 4 over 1, and so on. Is negative 9. Negative 9 times negative 1 is 9. 11 plus 9 is 20. And 20 times negative 1 is negative 20. 20 minus 20 is 0. The remainder is 0. That's exactly what you should get if they're going to be linear factors. So there's the first one. We started with a degree 3. And now we're down to a degree 2. Do you know how to solve for a degree 2? I should hope so. We've spent most of the year working on quadratic functions. So we need to factor this and solve for x. I'm going to bring down this factor. That is the factor x plus 1. Remember, if I solved it, I would get negative 1 to use in synthetic division. And then we have x squared minus 9x plus 20. Factor. If it factors, if it doesn't factor, then what? We use the quadratic formula. X times x is x squared. Factors of 20 that are going to add to 9. That would be negative 4 -5 adds to -9, and -4 times -5 is +20. And then you solve. You get x equals -1, 4, and 5. Find the real zeros. We're going to start by finding the possible rational zeros. Factors of 12, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And factors of 10, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. P over Q, we get 1 over 1, 2 over 1. So I'm going to start with those ones. All over 1. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus and minus 12. And now everything over 2. So 1 over 2 would be 1/2, plus or minus 1/2. 2 over 2 is 1, and I already have that. 3 over 2. 4 over 2 is 2. 6 over 2 is 3. 12 over 2 is 6. Now 5, 1 over 5. 2 over 5. 3 over 5. 4 over 5, plus or minus 6/5, plus or minus 12/5, and now we're going to do over 10. Plus or minus 1/10. 2/10 is 1/5. 3/10, 4/10 is 2/5. 6/10 is 3/5. 12/10 is 6/5. Those are all of the possible rational zeros. We're going to use the calculator to help us start this process of a degree 4. 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12. Graph. All right, so we're going to look at our window. 4 on both ends. Let's do a minimum of 4, a maximum of 4 on the x-axis. All right, they look to be all fractions here. All right, let's try, this looks like it could be a -1/2. Why don't we start with a -1/2? Setting this up, we have x to the 4th, x to the 3rd, x squared, x, and the constant. So we're all set on our numbers. We have 10, -11, -42, 7, 12. We're going to try a -1/2. Bring down 10. Half of 10 is 5, so -1/2 times 10 is -5. We get -16. Negative times a negative is a positive, and half of 16 is 8. -42 and +8, 34. Half of -34 is 17, and negative times a negative is a positive. 17 and 7, 24. And then half of 24 is 12, and that would be a -12, and 0. All right, we found our first 0. Again, this is a degree 4. And we are now down to a degree 3. we need to continue with the synthetic division. Let's see, what would be a good 0 to try? We got -1/2. I'm not sure if that's really at the halfway mark. Let's trace and see if we can glean any information this way. So it's 0.59, about 0.6. So which fraction is more like 0.6? Not really a half. So 5 into 10 would be 0.2. 0.4. 5 into 30 would be 0.6. Let's try a positive 3/5. All right, bring down the 10. And then 10 times 3/5. Just going to use a pencil, come over next to this. We're multiplying by 10. We know that we have 30 over 5, which is 6. -16 and 6 is -10. And so -10 times 3/5 will be a -6. We get -40. And then -40 times 3/5. These would cross cancel, so divide by 5, and we get -24. And there's the 0. So 3/5 works. We have a degree 4 divided by a linear factor to degree 3 divided by another linear factor brings us to x squared. So if I bring down these factors, we have, it's not x plus a half. How do you get a half? That would be 2x plus 1. If I solve 2x plus 1, I'd put the 1 on the other side. It'd be -1, and then divide by 2 would be a -1/2. So there's the factor for a -1/2. And a factor for 3/5 is going to be 5x minus 3. Solve for this. The 3 would go on the other side, and then you divide by 5. Then we have our quadratic, which is 10x squared minus 10x minus 40. We just need to factor this quadratic. So if we set that equal to 0, we have 10x squared minus 10x minus 40 equals 0. First thing that we see is that we can factor out a 10, monomial factoring. So I'm going to pull that 10 all the way out to the front. And that leaves x squared minus x minus 4. We are looking for factors of 4 that are going to add to -1, 2 and 2, 4 and 1. This is not going to factor, so we're going to have to use the quadratic formula. -1 is going to be a positive 1 plus or minus the square root of b squared minus 4 times a times c, which is -4. And again, remember that b was negative. This needs to be in parentheses because the negative is also being squared. Common student mistake. I hope that you have learned by now to put your b term in parentheses when it's negative. And then we have 2a, 2 times 1. We have 1. -4 times -4 is positive 16. So x equals 1 plus or minus the square root of 17 divided by 2. This is a real number. It's irrational. It's a decimal number that goes on forever. And so unless I'm graphing, I would change it to a decimal, but I'm not graphing, so I'm just going to give my final answer. We have that x equals, we have a degree 4, so we expect 4 answers. We have a negative half. We have a positive 3/5. And then we have 1 plus or minus the square root of 17 over 2. Final answer. Again, if I was graphing, I would definitely want to see decimals. But I'm not graphing. I'll leave my answer like that. Next example, ice sculptures. Some ice sculptures are made by filling a mold with water and then freezing it. You are making such an ice sculpture for a school dance. It is to be shaped like a pyramid with a height that is 1 foot greater than the length of each side of the square base. The volume of the ice sculpture is 4 cubic feet. What are the dimensions of the mold? Volume of a pyramid with a square base is going to be 1/3 times the area of the base times height. Area of the base is going to be x times x times the height, which is x plus 1. We have 1/3 times x squared times x, and then x squared times 1. We know that the volume is 4 cubic feet. All right, I'm looking for a polynomial. I'm going to use the reciprocal here, multiply by 3. We get that 12 equals x cubed plus x squared. And finally, we have a polynomial, x cubed plus x squared minus 12. And now we are ready to start our synthetic division. We have our possible P over Q is going to be factors of 12 over 1. So that's just going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. We have degree 3, degree 2. We're missing the x term. So we need to remember to fill in 0x and minus 12. So for our synthetic division, we have 1, 1, 0, negative 12. And 2 works. We started with a degree 3, and now we have a degree 2. So the factor for 2 would be x minus 2. And we have x squared plus 3x plus 6. We're looking for factors of 6 that are going to add to 3. 6 and 1, 2 and 3. Those do not work, so we need to use the quadratic formula. we can see here that we have an imaginary number. So we're not going to get any zeros from here. So the only zero that we have is 2. X equals 2. And what does the direction say? What are the dimensions of the mold? The dimensions then would be 3 feet, the height, and the base would be a 2 feet by 2 feet. That is the base.